screen share.
Present now, yes. Present now.
Then full screen.
Yes,
Your
full
entire
screen.
screen. Then you
That
will
I
get
want.
your screen. Then you click on that screen. Then you have to share it. Then your entire screen. Then you will see your screen. Then you click on that screen. Then option share will activate.
It is not coming actually. Here your entire screen, that window came, but when I click this share option, it is not activating.
Ma'am, share option is showing the blue.
Huh? Hello.
Ma'am, you have to tap the screen. Then only share screen will activate.
We will present it and you can just explain it. I'll just try. Okay. Just once again, why it is not sharing? Share your entire screen.
Then one screen will available on your tab. You click on that screen tab. Then share option will come. Otherwise, share option will be invisible.
This is visible. This slide is visible now.
No, ma'am.
Okay. Now this share, this screen I could get where it is showing that share and cancel. So the cancel button is activated, but the share button is not activated.
No, you have to click, ma'am. On
No,
screen,
I'm clicking,
whatever
but it
the
is not
screen.
clicking. I'm clicking, but it is not
No,
clicking.
ma'am. The screen shape will come in that box.
Share your entire screen. This
First you
tab
click.
came. Huh?
Okay. Then you in the box one screen will come. First you click on that. Then share option. Then share option you click.
Meet Google Com is
Yes.
sharing your screen.
Yes, ma'am.
Now shall I open my
Yes,
presentation?
ma'am.
Is it okay?
Now you share, ma'am.
Okay, so now it is visible.
Yes.
Okay, thank you.
Yes, ma'am.
Thank you. Okay, so I'm going to the full screen mode. Okay, is that okay? Is that okay?
Yes, ma'am. Yes, ma'am.
Okay. Thank you. So good morning, everyone. My topic today is characteristics and design of rigid pavement. Road transportation is recent times is a priority area in our country, and a lot of road development projects have been taken up by the government, by central government as well as the state governments, and a number of road development projects have been taken up, like the PMGSY, recently the Bharatmala project, several NHDP projects are coming up, and in all these projects a significant amount of roads are being constructed, widened, and upgradation has been taken place in many cases. Now, when we talk about road infrastructure, we have basically two broad types of roads. One is the bituminous road, and the other is concrete road. So the two roads have a difference in many aspects. In India, most of the roads are bituminous road, where the top surfaces are made of asphalt or bitumen layer, while in case of concrete roads, the top surface is made of cement concrete. The two types of roads have significant differences, not only in terms of the material, but considering those aspects, there are several differences, like the construction cost. In bituminous roads, the initial construction cost is much less as compared to concrete roads. The concrete construction is high, but at the same time, we have to see that for a bituminous road, as they are very much susceptible to moisture and temperature, so they are susceptible to several distresses. So they require frequent maintenance throughout their service life. So the maintenance cost is significantly high and periodical in case of bituminous road, whereas concrete roads, the maintenance cost is relatively less. We hardly require any maintenance, and so the durability of this type of road is much longer as compared to conventional bituminous road. So when we talk about the life cycle cost, the cost of concrete road is lower as compared to the bituminous road. Though it has an initial construction cost is higher as compared to bituminous road, but considering the maintenance cost and the durability and performance, the life cycle cost has found to be lower in case of concrete roads. So as a result, the government of India has now put several emphasis for the development of concrete roads in India. And in several new projects, we are seeing that a number of concrete roads are coming up. Now, there are several types of concrete pavement available or constructed in globally. So the types are, say, jointed plain concrete pavement or JPCP, jointed reinforced concrete pavement, continuously reinforced concrete pavement, precast pre-stressed concrete pavement, roller compacted concrete pavement, and so on. But not all are very popular. In India, we particularly have jointed plain concrete pavement in most of our highways. JRCP or jointed reinforced concrete pavements are much less, even in US. In India, it is not there. CRCP is also not constructed in any major project in India, though in US, several highways are constructed with this. Pre-stressed precast concrete pavement has just started in India. Just a pilot project has been done in Nagpur, recently completed. But in no other place. So roller compacted concrete pavement, of course, it is found in several urban or semi-urban or rural areas. This is available in India. Self-fill concrete pavement is also another new type of concrete pavement, particularly for rural roads. And this type of pavement are constructed in several PMGSY roads. And it is developed in IIT Kharagpur. Pervious concrete pavement is also a new type of concrete pavement, though in no major road projects it has been constructed, but they are useful in some urban areas or for low volume roads. And concrete overlay or white topping is another new type of concrete pavement which is coming up in a big way. And in several city areas, this has been constructed, like Pune, Mumbai, Bangalore, Hyderabad cities, and also in Eastern India, we have started a pilot project and the construction has just been completed. So, and this is a very effective rehabilitation measure for deteriorated roads. So, several types of concrete pavement are there. But our today's lecture, I will focus mainly on jointed plain concrete pavement, which is constructed mainly in the highways and also in other city roads and all in India. Now you can see here a schematic diagram of jointed plain concrete pavement. It has several components. Components are, the main thing is the concrete slab, which is the top layer. And this concrete slab, you can see here, it has lines that denotes the joints. The joints are provided in transverse as well as in longitudinal direction of the pavement. And the slab is supported on a foundation And this foundation is a combination of base layer and sub-base layer and then the compacted subgrade. In the transverse joint, along the transverse joint, we have dowel bars. They are mild steel dowel bars, mild steel rods, and placed at specified spacing along the transverse joint. And along the longitudinal joint, we have tie bars, mainly to hold the two panels in their position. So the basic characteristics of concrete pavement is that it has high flexural strength of concrete slab. The concrete slab itself is it had high stiffness and strength. So the flexural strength of concrete slab is high, and the influence of subgrade strength is less in case of concrete roads. Particularly whenever the subgrade soil is poor, concrete roads are preferred, because the strength and performance of the concrete pavements mainly depend on the characteristics of the top concrete slab. So the influence of the underlying layers are much less in case of a rigid pavement, whereas it is different in case of when you compare the bituminous or flexible pavement. In flexible pavement, all the layers, it also consists of several layers, and all the layers actually contribute in taking up the load. Whereas in case of concrete pavement, it is the top concrete layer that is responsible for taking up the major load. So the influence, the foundation also has influence definitely, but their influence is significantly or comparatively less as compared to the top slab. So the top slab, because of its high rigidity, has small deflection, and as I showed you in the picture, that it has joints, so it is not continuous. It has joints, so they are finite slabs with joints. In case of bituminous pavement, you don't find these type of joints unless there is a construction joint, but they are continuous. But in case of jointed plain concrete pavement, they are not continuous. They are called finite slabs because the joints are present in transverse as well as in longitudinal direction. So the main components for a rigid pavement is that the concrete slab, the foundation, the interface, and the joints. So the foundation is composed of base layer, sub-base layer, and the subgrade and the compacted subgrade. So in some cases, when the traffic volume is not so high, base layer or sub-base layer may be omitted. But in generally in case of highways, sub-base and base layers are present. And in between the concrete slab and the base layer, which in India it is generally a cement-treated layer or dry lean concrete base, and in between the concrete slab and the base layer, there is a polythene sheet. Polythene sheet is provided to make the interface a smooth interface. So interface in case of concrete pavement is an important component, and because if we do not provide the interface bond breaker, then the characteristics and behavior of the concrete pavement will change. So I will discuss these things in detail a little later. And joints. So joints are important components. As I said, that we have several types of joint, both in transverse and longitudinal direction. Subsequently, we will discuss these things. So concrete slab is the main component. It is made of plain cement concrete. In India, we have concrete pavement made of plain cement concrete or pavement quality concrete. And this is the main component that is responsible for load carrying. Foundation is composed of subgrade, base, and sub-base layers. And the strength is expressed by a parameter termed as modulus of subgrade reaction. Here we assume that the foundation is a Winkler foundation. That means it is assumed that it is composed of a number of springs supported, and the shear strength is not there. So it has only one parameter, that is the spring stiffness, and this for subgrade we express this as the modulus of subgrade reaction. And base and sub-bases are provided for uniform and firm support and to level the surface. And of course, as I mentioned, a polythene sheet is present in between the concrete slab and the base layer. Now, as I said, interface is an important component. So interface may be bonded or unbonded. When the slab is cast directly over the base or sub-base, then the interface is completely bonded, and it becomes rough interface with very high friction, because the two layers they cannot move easily, so they are fully bonded, and so they have in between they have a very high friction. So we call it a rough interface or a bonded interface. Unbonded interface, in this type of pavement, we have a bond breaker in between the concrete slab and the foundation. This bond breaker could be a polythene sheet, could be a thin asphalt layer, or could be any other layer. But in India, we generally have a 125 micron polythene sheet, which is used as a bond breaker. And in case of smooth interface, what happens? There is very little friction. So the slab can move over the base easily. And this is actually done to take care of the seasonal temperature variation. These things also we will discuss subsequently. So two types of interfaces are there: bonded interface and unbonded interface. And advantages of these are also both cases are there. In case of bonded interface, the underlying base layer actually contributes in taking the total load. Okay, so because the neutral axis now shifts, maybe the strength of the two layers are different for concrete slab and the base layer, but since they are completely bonded, so the neutral axis shifts. So finally the stress developed on the concrete slab is less. So in that case, we can have a lesser thickness requirement for bonded interface case. Whereas in case of unbonded interface, it is only the concrete slab that is responsible for taking the load, and the underlying base layer doesn't contribute because there is a bond breaker. So in this case, comparatively, the thickness requirement is more. But this is advantageous to take care of the seasonal temperature variation or daily temperature variation even. So when there is a difference in temperature, both seasonal, particularly seasonal or daily, so in that case, unbonded interface is preferred. So in India, we have varied seasonal variation all over our country. So in the IRC code, it is considered that we will use an unbonded interface with a bond breaker in between the slab and the foundation. Now, joints in concrete pavement are of several types: contraction joint, construction joint, expansion joint, and isolation joint. Now, the joints are provided to control the cracking in concrete pavement, in concrete slab, rather, due to shrinkage or thermal contraction, moisture variation, etc. And they are provided in transverse as well as in longitudinal direction, as I have shown the pictures of joints. The contraction joints are provided when the concrete slab is cast continuously, but joints are provided by saw cutting it after around 18 to 20 hours of construction, and these joints are saw cut up to a depth of 1/3 to 1/4 of the concrete slab, and so that the joints cracks are formed below that joint. And this is called contraction joint, to allow the cracks due to thermal contraction. In concrete, the cracks are almost inevitable. We cannot avoid, it is very difficult to avoid cracks in concrete slabs. So by providing these contraction joints at a designated location, we ensure that if there is a crack, that will occur at those designated locations. So the designated locations are the location of the contraction joint by saw cutting, So cracks, if they form, they will form at the weakest locations. So we have found that the cracks are developed below that saw cut. And since we know the location of the saw cut, we can take a measure so that that location is not weak. So what we do, we provide dowel bars there, and dowel bars can transfer the load from one slab to the other. So contraction joints are provided by saw cutting the slab to allow the cracks to occur due to thermal contraction or expansion, contraction mainly, and this can be taken care of by providing dowel bars at that location. Construction joints are provided to separate the successive construction activities. Suppose after a day's work, we have to stop somewhere. So there we need a full depth joint. Contraction joints are not full depth, but construction joints are full depth joints because we have to stop somewhere after a day's construction. So that is a full depth joint, and obviously there we should have to provide dowel bars. Expansion joints are nowadays not common in India. Code doesn't allow for not much expansion joint, and expansion joints actually are provided to permit the thermal expansion of the slab without damaging the adjacent slab, so that the slab can expand. But nowadays these contraction or construction joints can take up, so expansion joints are not very common. Isolation joints are provided to isolate the pavement from adjacent structures. Suppose there is a building or there is a bridge, so you have to provide a joint. So that is the isolation joint. Now here is just a schematic diagram of the joints. This is a contraction joint. As you see, the saw cut is done after construction, and it is 1/4 to 1/3 of the slab depth. And below that, there is this zigzag line is that it shows that the crack will develop below that saw cut. So this is the contraction joint, which is undoweled. And now what we do, we provide a dowel bar at that location. During construction, we know it that this is the location of the joint. So we provide a dowel bar at that location. So this is the contraction joint with dowel bar. In case of longitudinal joint also, we can have that type of contraction joint. So it could be untied. That means there is no tie bar. And in case of tie bar, sometimes we also provide tie bar. So that is tied contraction joint, particularly in the longitudinal direction. So here is some pictures. You can see that this is saw cutting machine, and after the construction it has to be cut, and it is not a full depth. As you can see here, it is up to 1/3 the slab depth. So saw cutting is formed and the groove in the slab to create a weakened vertical plane. And since it is weakened, a crack is developed. You can see here in this next picture that a crack is developed below the saw cut. So below the joint there is a crack. That's what we wanted. Otherwise, the crack may form at any other location, and there the dowel bars are provided. Now, construction joints must have dowel bars because that is a full depth joint. So load has to be transferred from one panel to the other. So dowel bars has to be provided in construction joint. So here you can see that dowel bars in transverse joint, and in case of longitudinal joint also, we have to provide tie bars, not dowel bar, but tie bar. But in the longitudinal direction, if it is a construction joint, you have to provide tie bars. There is just some pictures. You can see that this is a construction joint, the full depth joint, the face you can see, and the dowel bars are coming up. So when the next day the construction will start, it can start from here, and it is connected by these dowel bars. So here in this next picture, is one side is the dowel bar and the other perpendicular to it is the tie bar. So the construction, when the next construction will take place, they will be connected by these dowel bars and tie bars in the construction joint. Now this is a schematic of the expansion joint and isolation joint. Sometimes when there is no no dowel bars or tie bars, the slab at the edge are thickened. So it is the thickened slab at the edge and it is connected. And sometimes it is possible that we can provide dowel bars. So you can see here that the expansion joint with dowel bars. Now all these joints, another thing, all these joints need to be properly sealed, because otherwise the water and other dust materials may percolate and will go deeper to the inner layers and can damage the pavement. So it is very, very important to seal the joints in case of JPCP, particularly the construction joints. And in India, we all, we all sealed, all the joints are sealed, whether it is a construction joint or it is a contraction joint, it is sealed because the width of the joint is significant. In case of construction joint, it is more than 5 mm, so it has to be sealed. There are guidelines also in India that what material you should use for sealant. So it has to be sealed properly so that it is impermeable for water or dust materials or other deleterious materials to enter. And often it has been found that the joints, if it is not properly done, not properly saw cut or not properly sealed, they are the locations of distresses. So construction has to be done in a proper way so that we can have a long-lasting pavement. Now for concrete pavement, it is particularly for jointed plain concrete pavement, it is very important to transfer the load. So load transfer is taken place at the joints. So joints, as you have seen, the joints are provided with dowel bars in the transverse direction, and in the longitudinal direction it is with tie bars. But tie bars are not meant for taking or transferring the load. They are just for tying the two slabs in their position. But the load transfer devices are actually the dowel bar system. So for all highway pavements, we are providing dowel bars. But load is transferred other than dowel bar system also. It is due to interlocking action of the aggregates. Particularly for low volume roads, sometimes dowel bars are not provided. So in that case, load is transferred through the interlocking action of the aggregates. But for high volume traffic roads, you have to provide dowel bars. And here the joint spacing is also longer. And dowel bars are mild steel dowel bars and connecting the adjacent panels at the mid depth of the slab. And they are of certain length, diameter, and that has to be provided while construction. And these dowel bars actually transfer the load from one panel to the other panel. In case of aggregate interlocking action, this is also another way of transferring load from one panel to another. It is given when the traffic volume is low, particularly the joint spacing is also less as compared to the dowel bar system. And here the interlocking action of the aggregate actually is responsible for transferring the load from one panel to the another panel. So deformed tie bars are sometimes used to hold the two adjacent panels so that aggregate interlocking action is taking place, because over a period of time that there may be more gaps and the aggregate interlocking may be gradually diminishing. So tie bars are provided so that aggregate interlocking action can take place even for longer duration. Now here you can see that as a schematic diagram, load transfer at joints with dowel bar system. If there is no dowel bar, when the load is coming on one slab, it will deform. That slab, the loaded slab will only deform, but the other slab will not deform. So whenever a vehicle will go, so there will be a jerk, and by continuous movement of several vehicles, the edges of the joints will be damaged. So here there is no load transfer without any dowel bar, no load transfer. So this will cause serious damage to the pavement. While in this case, dowel bars are provided So what happens when a load is coming on one slab? It will deform, and double bar, because of the presence of double bar, the other slab, the adjacent slab or the unloaded slab will also deform. Not equally, but almost equally. So with this, there is no jerk on the movement, and also the edges also will not be distressed. So the pavement will perform um, normally, and the load transfer also will take place. So here what happens, if the load transfer is very good, then both slabs will deform almost equally. So and if the load transfer is not that good, so then the loaded slab will deform more and the unloaded slab will deform less. So it is important to have both the slabs deflection are nearly equal. So more is the deflection, or as close as the deflection of the unloaded slab to the loaded slab, better is the load transfer. Here you can see that load transfer with aggregate interlocking joints. Here, if there is more distance between the two joints, the two edges are more, then there is no load transfer. So one slab will deform, the other slab will not. But when it is connected with some mechanism, either tie bar or with proper aggregate interlocking action, then there is load transfer. So both slab will deform and there is a transfer of load and the no distress also at the edges of the pavement. Now, load transfer is important consideration for concrete pavement performance. So it is important to transfer the applied wheel load from one slab to the other slab, and it is actually an indicator of the performance of the pavement. So the performance is expressed in terms of parameter which is termed as load transfer efficiency. Load transfer efficiency is the ability to transfer the load from one panel to the adjacent panel through the joint. If the load transfer efficiency is less, then there are several distresses at the joint: faulting, pumping, corner breaks. There are several types of distresses, and I said earlier also that joints, if it is not properly constructed or treated, these are the location of distresses in rigid pavement. Load transfer efficiency is expressed in percentage, and it is quantified as the ratio of the deflection of the unloaded slab to the deflection of the loaded slab in percentage. So as you can see from the previous slides, that I mentioned that closer is the deformation of the unloaded slab with the as compared to the loaded slab deflection, better is the load transfer. So this is also, you can find it from this expression, that if delta UL or the deflection of the unloaded slab is very close to delta L, then we have almost 100% efficiency. 100% efficiency is a theoretical thing. As close as possible, over 90% is good enough. Okay. So, so the performance of the joint is expressed in terms of its load transfer efficiency. So it is very, very important we have a good load transfer efficiency for a pavement to perform longer. Another thing I would like to tell, that in case of aggregate interlocking, there is no double bars, but the main parameters that is responsible for aggregate interlocking is joint width. The width should be very less, maybe 0.1 mm to maximum 0.5 mm. Okay, so that should be the width of the joint for aggregate load transfer mechanism. And joint width is the most important parameter for aggregate load transfer, aggregate interlocking load transfer mechanism. If the width increases, load transfer will reduce. Another important parameter is the aggregate size, because it is the interlocking action of the aggregates. So aggregate size is also a very important parameter for load transfer. Also the roughness, okay, also the roughness of the surface is important in case of aggregate interlocking action. Because as you can say that, okay, in case of a construction joint, we have a full depth joint. This is the joint width is very less. The aggregate size is also okay, but there is no aggregate interlocking load transfer. Why? Because the aggregate interlocking load transfer is not taking place because of the smooth interface. Okay, so that location, the interface is very smooth. So the roughness of the cracked surface also plays an important role in case of aggregate interlocking load transfer mechanism. So the most important parameters are the joint widths, the size of the aggregates, and the roughness. Another thing is the effect of temperature. Temperature has a significant influence on the performance of jointed plain concrete pavement. We have the effect of temperature twofold. One is the daily variation of temperature, another is the seasonal variation of temperature. In case of daily variation of some temperature, when the top surface temperature is more as compared to the bottom surface temperature, this happens in the daytime. The slab is curled like this, as you see, slab curling downward when the top temperature is more as compared to the bottom temperature. So there is a curling like this. While in case of night time, when the top temperature is less, whereas the bottom temperature is more, because concrete is not very good in temperature conductivity. So the by the time the temperature increases at the bottom, there is evening, so or night time. So the top temperature decreases, whereas the bottom temperature is still at a higher level. So in that case, there is a curling upward, right? So this is the effect. Curling upward effect is found in the night time, whereas the curling downward effect is for the daytime variations. In case of seasonal variation, actually there is an increase in temperature and decrease in temperature. Increase in temperature during summertime and decrease in temperature during the winter time. So because of that, there is expansion or contraction, and this is taken care of by that unbonded interface or the polythene sheet. Because of that, this increase or decrease in temperature, uh, slab movement can take place because of this variation. So the unbonded interface can take up this seasonal variation of temperature in a much better way. Now here are some pictures of the failures or distresses of concrete pavement. You can see that shrinkage cracks are very common if the construction is not proper, not cured properly, not saw cutting in time. So there are several cracks occur in concrete pavement. So construction is very important in case of concrete pavement. You have to construct it properly with proper care, and then only it can serve longer with more durability. So this is a picture of shrinkage cracks. Corner cracks are also common. Corner cracks, because these are the locations where stresses become high. So this is also a common type of distress in case of concrete pavement. This longitudinal cracks. Sometimes we found that along the length of the pavement, along the traffic movement, cracks are there. So this longitudinal cracks, this is transverse cracks, maybe due to structural reason or due to temperature reason or due to foundation reasons that we are not discussing here. This is faulting type of distress. Here, because of the foundation problem, joints have been separated, and this type of distress happened with this, and this has been repaired with stapling. And this is another type of distress, blow up at transverse joints. If the joint width is not sufficient, then due to expansion, thermal expansion, the two slabs hit and there is a blow up type of distress, and this creates a lot of energy, a lot of sound, and this is a very serious type of distress. So it is very, very important to properly design the joints. Another is spalling from bad construction joint. You can see here that this joint location there is distress. pop out, some portion of the concrete has come up, and this type of distresses are found mostly near the joints. All these are near the joints. So these are several types of distresses. Some are due to load associated distresses like longitudinal cracks or transverse cracks. Some are joint related distresses, and some are construction related distresses, or some are foundation related distresses. Now, when it is a structural type of distresses, then it is due to the stress which is coming up higher as compared to its flexural strength. So, a proper design is needed for the concrete pavement. Now, several investigations have been done on concrete pavement, and analysis has been done with latest technology, and with finite element modeling. This has been done. Here you can see that this is a two panel concrete pavement. One side is the shoulder, and it has base layer and sub base layer, and below it is the foundation, and in between there is also a polythene sheet, so to make it an unbonded interface. So now concrete pavement can be analyzed, and with loads due to wheel load coming on it, and with that we can find out where is the critical location for stress on the pavement, and how much is the stress. So from this type of modeling, we can find out that the location of critical stress, the amount of critical stress, and for that how we can estimate and further design our pavement. So in recent years, we have done analysis of concrete pavement using finite element modeling. This has been done by me only, and this has been replicated in one national highway. And so you can see here that the concrete slab, which is 300 millimeter thick slab, has been modeled here. Below is the 150 mm DLC, and below it is the 150 mm WMM layer with mixed macadam layer, and the foundation, which is assumed for the analysis as Winkler foundation. So it is represented by these spring elements, and it is designated by these straight lines, straight linear elements. So this is the spring foundation, and here is a transverse joint that has also been modeled with dowel bar system, and dowel bars are along the transverse joint. And you can see here that this is a longitudinal joint also is there with aggregate interlocking action, and a 1.5 meter, and this joint is provided to connect the 1.5 meter wide shoulder. So this has been modeled in finite element method in ANSYS, and with different amount of loading, it has been found that where is the critical stress and what is the amount of critical stress. So this is just a diagram of a finite element model of a concrete pavement, and nowadays all these analysis have been done using this finite element modeling, and the design is also based on some finite element analysis work. So here you can see that in this analysis, in the finite element modeling, concrete slab is assumed to be a linear elastic isotropic material, and this has been modeled solid brick element, and the foundation, which is composed of base, sub-base, and the compacted subgrade. Base and sub-base are also modeled as linear elastic isotropic material and have been modeled with solid brick element, and the subgrade is modeled as Winkler foundation, and this is the just a schematic representation of that. Okay, this is the front view. So this is the representation. The Winkler foundation is represented, and the brick elements for slab, base, and sub-base are represented like this. And also there is a polythene sheet. It is of no thickness almost, so it is 125 micron, as you can see. So it is not shown here, Of course, I should have written it that a slab polythene sheet is there, but that has been modeled. That has been modeled here, so that takes care of the unbonded interface. Now, this is I just give you just one picture of it, but the detailed analysis are there. Those who are interested, you can go through some of my research works. I can give you the link also. So this is the finite element modeling of the joint with dowel bar system. You can see here the dowel bar has been modeled, and the one side it is with cap and with dowel looseness, so that has been modeled. And this is the beam element for dowel bar, and they are connected to these contact elements. So this dowel bar can take up the load and can deform, and so that we can find out that what is the stress coming on it, on the slab, and what is the load transfer from one slab to another. We can measure, we can have the deflection of both slabs, and from that we can find out the efficiency of the joint as well. So this is also the finite element modeling of the aggregate interlocking action. You can see here that this is the crack below the socket. One side is the loaded slab, another side is the unloaded slab, and they are connected to this aggregate interlocking, which is represented by a set of springs. So these spring elements connect the nodes of the adjacent slabs, and actually a new modulus value was introduced by me only, and this is the expression for modulus of interlocking joint, and it is a function of the crack width and interlocking ratio. Interlocking ratio is a function of which is IR, expressed as IR, is a function of crack width and maximum aggregate size in the concrete. So this is similar to modulus of subgrade reaction to represent the strength of subgrade. So here we represent the strength of the cracked face. So this is by this modulus value, modulus of interlocking joint. So the details are there. I'm not going into much detail. So here also is the interface. As I said, this is the unbonded interface. An unbonded interface has been modeled here with this contact elements, so that it can take care of the curling effect, curling upward or curling downward effect. So the slab and base are modeled, and with this contact elements, this interface is modeled. So this interface can take up the curling effect. So when there is upward curling or downward curling, there is a gap. So these contact elements can take up those things and can very well represent the interface behavior and the curling characteristics. Now, these were some of the analysis, the advanced or latest analysis using finite element method. Now we will discuss about the design of the jointed plain concrete pavement. And this design, so for the design of concrete pavement, definitely it is based on the analysis. So for the design of concrete pavement, the design elements are concrete slab thickness. That means you have to design the concrete slab, you have to design the base and sub base, mainly the thickness, the joint type, the joint spacing. You have to design the dowel bar as well as the tie bar. So these five are the design elements for the rigid pavement. So for the design of rigid pavement, we have two criteria. One is the critical stress criteria, another is the fatigue criteria. The critical stress criteria is due to the effect of axial load and temperature. As I said earlier, the temperature has a significant influence on concrete pavement response. So it is actually the combined effect of axial load and temperature. So the critical stress we have to check for combined effect of axial load and temperature. So one criteria is critical stress criteria, another is fatigue criteria. It means all pavements are subjected to repeated loading. So because of that, it may fail much before its strength. So this is called fatigue. So we have to check our pavement against fatigue. The pavement should be safe against fatigue. So this is due to repeated axial loads. So for the design of concrete slab, we have to check two criteria. One is critical stress criteria, another is fatigue criteria. And the design is done in India as per the IRC 58 2015. This is the guideline for design of rigid pavements for highways. So I will discuss the salient features of the IRC 58, not the entire design procedure, But what are the considerations and what are the basis for these considerations, I will discuss for this IRC 58. Now in India, we have a typical jointed plain concrete pavement. The standard panel size is 4.5 meter by 3.5 meter. Concrete slab depth, it varies 250 to 450 mm. We have base layers. It may be a cement treated layer or a dry lean concrete base. Generally, the thickness is 100 to 150 millimeter. Sub base, it may be granular layer or wet mix macadam is most common nowadays. The thickness may vary from 150 to 300 mm. And the interface between slab and base, as I said, is a polythene sheet. We provide a polythene sheet of 125 micron thickness. It's very thin, just a very thin polythene sheet of 125 micron thickness. And the pavement quality concrete is M35 to M40. So the grade of concrete we generally use is M35 to M40. For M40 is the standard thing. That means the compressive strength is 40 megapascal. Joints are saw cut up to the 1/3 the slab depth, and it has to be cut within 18 hours of construction, both in transverse and in longitudinal direction. So if we delay the saw cutting, there will be problems. That means cracks may form, and in many cases it has been found that cracks are formed because of the late saw cutting. So it has to be cut within 18 to 20, maximum 24 hours of construction, both in transverse and longitudinal direction. Dowel bars, depending on the slab thickness, varies from 30 to 40 millimeter in diameter. Length is also 300 to 400 millimeter in length, and spacing 250 to 300 millimeter. You have to design the dowel bar accordingly, but the range is like this. And the dowel bars are coated with epoxy so that it is not rusted easily. So it is coated with epoxy, and one side is with plastic cover. That means so that it can move. That means there may be a little movement because of the thermal expansion or contraction. So to take care of that, it is covered with plastic sheet on one side. And tie bar diameter varies from 12 millimeter to 20 millimeter. Length is also 1 meter to 1.5 meter, and spacing is 600 to 800 millimeter along the longitudinal joint. So this is the standard we follow in India based on the thickness, range of thickness and loading conditions. This has been done. But when we will design it, you have to design the dowel bar as per the loading and subgrade condition. Okay. Now we will discuss about the design guideline IRC 58 briefly. So the factors that govern the design are the design period, the traffic characteristics, the soil characteristics, and the climatic characteristics. We normally design our rigid pavement for 30 years. So that for that period, that means for that period of time, we also have to consider the traffic. So for traffic characteristics, the inputs what we need is the traffic volume, the composition of traffic, whether it is single axle, tridem axle, or so. Axle load spectrum, that is at what range of load the axle, the vehicles are. So that is the axle load spectrum. We need to have that input. The tire pressure, the wheelbase characteristics, that is the distance between the two front and rear wheels, and the lateral placement, and the directional distribution from this side to that side. Soil characteristics is important because ultimately all the structures are supported on soil. The subgrade characteristics, the subgrade, subbase, and base strengths are important. The climatic characteristics, temperature and moisture. Temperature, as I said, it has a significant effect. Both the daily variation of temperature as well as the seasonal variation of temperature has a significant effect on concrete pavement response. So temperature characteristic or the temperature variation is important. Also, moisture also has an effect on the concrete pavement response. But the response of the effect of moisture is actually the reverse as that of temperature. So we generally neglect this effect, and also this effect is much less as compared to temperature. So for our design purposes in India, we are not considering the effect of moisture. Now, wheelbase characteristics. We have the wheelbases of trucks generally ranging from 3.6 meter to even more, maybe 5 meter or so. So for the commonly used spacing of transverse joint in India, as I said, is 4.5 meter. So if it is 3.6 or so, we can consider. So if the axle spacing is more than 4.5, that is not contributing much to the stress development. So wheelbase characteristics is important, and we should know the wheel spacing. If it is more than 5 meter, so only one rear axle is contributing in developing stresses. Because the other axle will go to the other panel. So if the actual spacing of the transverse joint is different from 4.5 meter, then you have to do the analysis accordingly. You may have to do the FEM analysis and do those calculations for estimating stresses. The design lane with maximum number of heavy commercial vehicles has to be considered for the design lane, and each lane of a two-way two-lane highway and the outer lane of the multi-lane highways can be considered as the design lane. So you have to find that which is the most critical lane, and that lane will be the design lane. Now for design traffic, the legal axle load limits in India is for single axle it is 10.2 ton, tandem axle 19 ton, and tridem axle which is 24 ton. But recently it has been increased. The legal limits have been increased. But this is as per the IRC 58/2015 code. So, but in most cases we found that the vehicles are overloaded. So this is a real problem in India. We have overloaded vehicles, and our pavement is designed for these legal loads. So there may be chances of distress due to heavy load. So proper implementation of the laws should be done so that this overloading vehicles are stopped on our highways and the roads are not damaged and it can last long. So for that we have to do axle load survey to know that the range of loading on the highway. So design traffic volume survey is done based on 7-day 24-hour count, axle load survey for single, tandem, tridem axle loads. And also when we do the axle load survey or traffic volume count survey, we have to, and we do it for design, say for 20-30 years or so. So you have to also use the growth rate, traffic growth rate factor. So if no data is available, a minimum 5% growth rate has to be considered. And otherwise you can, the common method is that you have to find out the growth factor based on the past traffic data. There are several methods of estimating the traffic growth rate, elasticity model and others. So you can find out the traffic growth rate using traffic survey and other secondary data. And if no other data is available, minimum 5% traffic growth rate you have to consider. The design traffic, the design cumulative number of commercial vehicles during the design period is estimated using this equation. This is 365A into 1 plus R to the power n minus 1 by R. It's the cumulative number of commercial vehicles. A is the initial number of commercial vehicles per day, the CVPD. R is the annual growth rate, and N is the design period. So if the total cumulative number of commercial vehicles are estimated using this equation. Now the effect of temperature, positive temperature differential during daytime you have to consider, and negative temperature differential due to night time is considered. And in the IRC code, a separate table has been given. Based on that, you can find out what is the temperature gradient. That means what is the difference between top and bottom temperature based on the thickness of the slab. This has been done by CRRI several years back on different states in India, and from that they have come out with this table, and from that we can find out that what is the temperature gradient across the slab depth. So temperature differential recommended for 150 to 400 millimeter slab thickness, and that from that we can find out that what is the variation of temperature across the slab depth. But one thing is important here, that this temperature gradient was given assuming that the temperature variation across the depth is linear. That means from top to bottom it is varying linearly. But in actual practice, it has been found that the temperature variation is not linear from top and bottom. It is actually a bilinear curve. A non-linear, you can present it as a bilinear as well. So it is actually non-linear, particularly the daytime temperature variation. That means when the top temperature is more as compared to the bottom temperature, it is a non-linear variation. While the negative temperature variation, it has been found that it is mostly, you can express as approximately a linear variation. So, and this also we have tested in our laboratory also, and in some testing also in the field also we have seen it, that this variation is this nonlinear variation can be clearly found out. So here is one variation. You can see the variation in daytime is much more as compared to the night time. So the daytime variation is non-linear, night time can be represented more or less a linear variation. However, in actual practice, we do not see the curling on slab. A heavy slab is not seen that it is curled up or down, because there are restraint provided by the slab, self-weight, and also the dowels also provide the restraint. So we do not see the curling up or down, but because of that, stresses are developed, and these stresses are called temperature stress or curling stress. So these curling stresses are developed because of the temperature variation, and when the top temperature is more, then the slab is curled downward, and the tension is developed at the bottom. So, and if that stress exceeds the strength, there will be cracks. So we call it a bottom-up cracking. And in the reverse case, when the top temperature is less and the bottom temperature is more in nighttime condition, and in that case, when the stress exceeds the critical limit, then the cracks may develop from the bottom and it goes down. So this is called top-down cracking. So that we will discuss also little later. Now, another important consideration in the IRC code has been done here is the zero stress temperature gradient. This is an important thing, that whenever always the pavement is constructed cast in situ. So always there is some temperature gradient or some temperature effect on the slab. So when we construct it, if it is done in the, say, daytime or nighttime, anytime. So when it is constructed, because of its plasticity, the top surface is flat. Okay, the top surface of the slab remains flat. But maybe in that case, there is some gradient, right? So because of that positive temperature differential, suppose it is in daytime, there is some gradient, positive temperature differential across the depth. So it should curl downward, but because of its plastic nature, because it is casting at that moment and of the plastic nature, so the top surface remains flat. So as if there is some other force which is making this, which is obstructing its curling downward and making it flat. Okay, so this is actually due to the actually due to this effect of this plastic stage, they are remaining flat, and this inbuilt thing, as if this opposing stress is due to an equivalence of some negative temperature gradient. So this is called zero stress temperature gradient, and it has been found that it is almost equal to a 5-degree negative temperature gradient. So that means it assumes that it is equivalent to a 5-degree temperature gradient, which actually opposing the downward curling of the slab. So this is called zero stress temperature gradient, and in the design we will use this. But when we will use the daytime temperature effect, so it should be a negative effect when we consider the positive temperature gradient. But in the design purpose, to make it safe, we are not deducting this effect. But when we consider the negative temperature gradient, we add this zero stress temperature gradient. Okay, that means the 5-degree temperature differential effect is to be added when we consider the negative temperature gradient stress. This is the curling stress due to negative temperature gradient. But for positive temperature gradient, the curling stress, we are not deducting this zero stress temperature effect. Now, maximum temperature differential assumed to be constant for the 6-hour period. So the design has been done for 10 a.m. to 4 p.m. for the daytime temperature effect, and for the nighttime effect is 0 to 6 a.m. 0 a.m. to 6 a.m. So that means for 6-hour period. So slab may be assumed to be free of curling stress in the remaining 12 hours period. Now the subgrade has been, as I mentioned, subgrade has been built as Winkler foundation. To represent the strength of subgrade, we use modulus of subgrade reaction. Modulus of subgrade reaction can be determined from plate load test, but it is not very convenient to do that test. So we can estimate the K value from CBR test, and the minimum effective subgrade strength is 8%. 8% CBR is recommended. So you can also estimate it from DCP test, and the tables are given in IRC 58. So from the CBR value, you can find out the effective modulus of subgrade reaction. And tables are also given if there are different types of bases, like if DLC is there with 100 mm or 150 mm, the effective K value will be different. So that also has been given. If it is a granular layer, treated or untreated granular layer with some thicknesses, the effective K value also will be different. So that also has been given in the table, so that can be directly taken up. Now, as I said, that bottom of cracking is when the critical stress is developed at the top of the concrete slab. And the critical stress is developed due to the effect of wheel load and also the temperature effect. So, bottom of cracking, the stress is developed at the bottom, and this is due to the effect of wheel load and temperature, positive temperature gradient. So as you can see that when the slab is curling downward, that means this shape, and the wheel load is also at the edge of the pavement. As you can see here that when it is single axle load, the critical location is in between two transverse joints, almost midway between two transverse joints and at the edge of the pavement. So this is the location for critical stress when the load is, single axle load is here. Similarly for tandem axle and for tridem axle, the critical stress is at the edge. Now when with this effect, the temperature effect is coming, positive temperature effect is coming, the maximum tensile stress is developed at the bottom of the slab. So in case of only wheel load, the maximum stress is also developed at the bottom of the slab, and in case of this type of curling or positive temperature gradient, maximum stress is developed at the bottom of the clamp. So that these two effects are additive, not algebraically, but additive, and that total stress can be found out from FEM analysis. And if that stress exceeds the tensile strength of the concrete, then there is a crack. So this is shown here that this is the crack starts forming from the bottom and it goes up. So it is called bottom-up cracking. We have to design against this. Similarly, for top-down cracking, when the wheel load is this location, you can see here for single axle, for tandem axle, for tridem axle, when the wheel location is near the joints, the front axle and the rear axle is like this. So then, in that case, when only wheel load is there, the maximum stress will be developed at the middle of the slab at the top. And when the curling effect is coming into it, that means the slab is curled upward. So in that case, also the maximum tensile stress is coming at the top and middle portion. So these two effects are additive, and the location you can see here that at the middle of the slab, this is the location for maximum stress. When this maximum tensile stress exceeds the tensile strength limit, there will be a formation of crack. So you can see here that a crack has been formed due to this combined effect of wheel load and temperature, and it starts from the bottom and going down. So it is called top-down cracking. So when we do the design of our pavement, we also have to consider this. So it should be safe against top-down cracking as well. Now, calculation of stress of finite element based analysis has been done, and this is IIT Slab 2 software has been developed to compute the flexural stresses. Of course, this finite element software is for a single slab, not considering the dowel bar or aggregate interlocking, but just for a single slab and to calculate the stresses. And as we have seen that the critical stress, critical locations are 3 locations: interior, corner, and edge. But for the design, it has been found that the edge loading is the maximum stress. So this analysis has been done for edge loading condition, and also for also it is taking consideration the temperature effect, both positive temperature gradient and negative temperature gradient, to take care of the bottom-up cracking and top-down cracking. So for bottom-up cracking, the front axles are not considered, because as you can see here that if there is a front axle, it will go to the other panel. So the front axle effect is not there. But in case of top-down cracking, both the axles contribute in developing stresses. And it has been seen from surveys and other things that the front axle has much less load as compared to the rear axle, so it is almost the 50%. So front axle load has been taken as the 50% of the rear axle load. So in the calculation of stresses, 4 conditions were considered: pavement with tied concrete shoulder for single rear axle, pavement without concrete shoulder for single rear axle, because this is for bottom off, only the rear axles will be considered; pavement with tied concrete shoulder for tandem rear axle, pavement without concrete shoulder for tandem rear axle. For top-down cracking, it is the pavement with and without tied concrete shoulder having front steering axle with single tire and front axle of the rear axle unit placed on the same panel. So it is on the same panel. So for top-down cracking, both rear axle and front axle will be considered. For bottom-up cracking, it is only the rear axle that has been considered. Now, stress charts have been developed based on that single panel analysis. Stress charts have been developed only for bottom-up cracking cases, and also, based on these results, regression equations also have been developed for bottom-up cracking cases. And for top-down cracking cases, only regression equations have been developed. No stress charts have been developed for top-down cracking cases, but you can find out the stresses from the regression equations. So this is a typical chart for estimation of critical stress or flexural stress on the pavement with different slab thicknesses. With a particular single axle load of 120 kilonewton, rear axle load, temperature differential is 8 degrees centigrade without concrete shoulder, and with different modulus of subgrade reaction values. So like this, there are several combinations, and there are a number of charts. Charts have been developed with different axle loads, combined with different temperature gradient, with or without shoulder, and with different slab thicknesses and with different modulus of subgrade reaction value. So from that, you can find out the stresses once you know all these values. This is a typical chart like that, and this is also another chart for a single axis load of 80 kilonewton with temperature gradient 8 degree and with tied concrete shoulder. So there are a number of charts you can see from the code, and you can find out from these charts the flexural stress coming on the slab. So similarly, the regression equation, as I said, for bottom-up cracking cases, that means it is a combined effect of load and temperature. P is the load and T is the temperature. So the stress is the critical stress for bottom-up cracking for K less than 80 MPa per meter. This is the equation. So several equations have been developed for different K values, and you can find out from that equation also the critical stresses. Either you can use the charts or you can use the equation. So for top-down cracking condition, regression equations have been developed, not the charts. And from this equation, you can find out the critical stress on the pavement once you know the load and the temperature differential. Now you have to design, as I said, so these spaces for all these critical stresses, the stress should be less than the flexural stress. If it is more, you have to change or you have to redesign the pavement. So the two critical condition, one is the critical stress condition. That means the stress developed on the pavement should be less than the flexural strength. Another is the pavement should be safe against fatigue. So cumulative fatigue damage principle has been considered for the design against fatigue, and cumulative fatigue damage principle has been considered for both bottom-up cracking and top-down cracking. So the equation is that summation of small ni by capital Ni should be less than 1. That means for top-down cracking case plus for bottom-up cracking case, this should be the cumulative fatigue damage should be less than 1. So small Ni is the predicted number of load or temperature differential cycles for the ith load group during the specified 6-hour period, either it is for daytime or for nighttime, and capital Ni is the allowable number of load and temperature differential cycles for the ith load group during the specified 6-hour period. So combining these two effects is the cumulative fatigue damage. So that should be less than 1. So the pavement should be safe against fatigue if this true effect is less than 1. Now stress ratio, what is the stress ratio? Stress ratio is the ratio of flexural stress to the flexural strength of concrete, and based on this stress ratio in the IRC 58 also it is given based on the PCA analysis. PCA is Portland Cement Association pavement design. So they have done the pavement design, and these equations have been developed from PCA, have been taken up from PCA. That means for different stress ratio, what is the allowable number of load cycles the pavement can resist. So if the stress ratio is less than 0.45, the concrete can sustain infinite number of repetitions, and if it is the stress ratio is within 0.45 to 0.55, you can estimate the allowable number of repetition using this equation, and if it is more than 0.55, you can find out the number of repetition using this equation. So erosion has not been considered here, and these are the design steps, and I'm not going into detail. I think I'm running out of time. I'm closing here, and I will be happy to answer questions. Hello?
Hello.
Hello?
Hello,
Yes.
good morning, ma'am. Ma'am, in
Yes.
chat box there are few doubts of the participants. So please take some theory.
Where is the chat box?
Right side.
Right side.
Yes, sir. After
Or
quickly there is
anyone
a
can
chat box.
talk also. Anyone can talk also. No problem.
Actually, ma'am, if they will talk, then there will be problem.
Just 1 minute. Yes,
Because
where
at
is
the
the
time
chat
the ma'am.
box? Yes. I can see it. Yes. Is it the one or no?
Yes.
Chat. Yes.
Yes, sir. In chat,
Uh-huh.
we have asked some doubts.
Yes, have analyzed the fatigue stress under repeated load. How to design dowel? Yes, dowel design I have not covered because of the time shortage. I have not covered dowel design. How to cast samples for roller compaction concrete in lab? In lab, it is difficult to construct in lab, but roller compacted concrete pavement can be constructed. It is comparatively simpler in construction and also performance. Uh, how much load through roller shall be applied in field? Okay, that has to be, you have to see it. Okay, that has to be based on finite element model. I would like to ask which FEM software you would suggest for FEM modeling. Both are good. I have used ANSYS for my work, but both software, ANSYS and Abacus, both are very good, very versatile, and they are at par. Okay, so they are not very friendly, I should say, but you have to learn a lot, and you have to spend a lot of time and learning the software. Not very user friendly, I should say that. Okay. Mm. Ashish Mishra, is it possible to use precast concrete slab in place of cast in situ construction? Is it used anywhere in India? Just only one pilot project has been done on precast concrete pavement. It may not be a complete replacement of JPCP, but yes, it is a very good option for repair works, repair of concrete pavement, even for repair of flexible pavement, because of the faster construction and that. But also you have a lot of challenge in construction of pre-stressed concrete pavement. So it may not be very comfortable to say that it can replace it, but it is, yes, another type of pavement. It has also some advantages, but also very challenges also are there. Uh, everyone doesn't design using FEM, mostly do Excel calculation. Is it necessary to do SPM analysis for designing? No, it is not necessary to do FEM analysis for designing, because the design charts and equations have been developed based on simple FEM analysis. So since you are not using FEM analysis, you can use these charts and tables for the design. For design purpose, FEM analysis is not necessary. But if it is a non-standard pavement, non-standard size of pavement, and other details, then only you can use separate analysis, FEM analysis, or you can do some new analytical methods also for doing. For analyzing or designing the pavement. For these design charts and equations, these are valid only for the pavement size 3.5 meter by 4.5 meter. So this is, you have to keep in mind. Other than this size, you directly should not use these equations or charts. Throw some light on two-lift pavement in concept. This is not the platform now. It's no time for that. Is white topping equally durable as a rigid pavement? Yes, white topping is also durable, and actually a lot of works have been going on white topping, and in fact we are also doing one pilot project in eastern India on white topping, and it has a lot of potential for the roads in India, particularly urban, semi-urban roads. May not be for very high volume roads, but for other type of roads, it's a very good option. Will curling effect happen in both transverse and longitudinal direction? Yes, it may happen, but there are restraints due to dowel bars and tie bars, and also the self weight. So curling effect may happen in both the directions. How to do the analysis of fatigue stress under repeated load in FE analysis? This is a long thing. You have to do it. This is no time for here to discuss. But if you are interested, you can discuss with me later. Does the width and length of tie and dowel bars affect the interlocking of aggregates in CC pavements? Width, yes, length of dowel bar and tie bar affect the performance. Dowel bar affect the performance of load transfer in terms of load transfer, but interlocking aggregates, no. Aggregate interlocking action to take place. The tie bar's function is just to hold the slab in their position so that they are in their position and so that aggregate interlocking can be maintained.
Hello.
Yes, Dr. Chore is. I think the time is up, or
Yeah,
you
I
can
think-
answer questions.
Yes, ma'am. We can, participants can ask more questions on the email and they can have more discussion with ma'am
Yes.
afterwards.
Okay.
Yeah. I think, thank you so much, ma'am. Thank you for the wonderful and well elaborated presentation on characteristics and design of concrete pavements. It was very nice to have you here in our short-term course. Thank you so much,
Thank
ma'am.
you. Thank you.
Thank you, ma'am.
Thank you. Thank you. Okay, when you have your next presentation?
Next is at 12 o'clock by Dr. Professor E. V. Raghavan.
Okay. So is the same link valid?
Yes,
There-
ma'am. Same.
Okay.
Yeah.
Thank you.
Thank you, ma'am.
Thank you. Nice to be also here. Nice presenting you in front of these audiences. So it's okay. Thank you very much.
Thank you. And dear participants, thank you for listening to this session. Our next session will start at 12 o'clock. So be there at 11:55. Thank you for now.